Hello. Are you getting my voice? 5:30. Jntuh,
సార్
వాయిస్ క్లియర్గా ఉందా?
క్లియర్గానే ఉంది
స్క్రీన్ విజిబుల్ ఉందా చూడు.
సార్ కనిపిస్తుంది.
చదువు.
యూనిట్ 2 పార్ట్ ఏ.
Disjoint sets, right?
ఎస్ సార్.
స్లైడ్ చేంజ్ అవుతున్నాయి చూడు చందు.
చేంజ్ అవుతున్నాయి సార్. సెట్ రిప్రజెంటేషన్ డిజాయింట్.
రైట్. Today I am going to start the second unit, and it is a very simple unit that will be covered in discrete mathematics like sets. So in this you will get one new concept, that is the Disjoint set operations only. You listen very carefully. Once you listen and you got it, no need to prepare it again. This unit is helpful in the fourth unit. So anytime if you got any confusion or any doubt, then you will ask. See the second unit. This your second unit is the Disjoint sets and backtracking. The first half is the Disjoint sets. Disjoint sets. It has only two concepts. One is the Disjoint set operations as well as the union and find operations. Only three concepts. These three concepts are very simple. So I will explain from the set onwards. So first I'm going to explain these sets. What is the set? So already you know, set is nothing but collection of distinct elements or unique elements. That means there is no common element in the set. Set of elements with unique feature, also named as distinct elements, is the set. Generally, the sets represent with capital letters, you know, already capital A, capital B, like. So here the set S1 is one set. It consists of 4 digits, that is 1 to 10, that will be represented with the braces. It is a set representation. It is simple representation of the set. Next, the set also represent in tree format also. Tree format like, suppose if we take three sets S1, S2, S3. S1 consists of 0, 6, 7, 8, 4 elements, 4 distinct elements. There is no common element. S2 has 3 elements. S3 has 3 elements. And that will be represented like general tree representation. The first element treated as a root element generally. Otherwise, you will take any element as a root. For searching purpose, first element treated itself it as a root. So for this 0, 6, 7, 8 are the children of 0. It is a set 1 representation. It is S1. So we can able to represent in the set format or this tree format. This is set representation. For the S2, this is S2. So from S2, the first element is the 1. It is treated as a root. Remaining 2 elements added to the 1, that is both are the children of the 1. Third one is 2, 3, 5 are the elements. 2 is the first element, that is itself it is a root, and 3, 5 are the children of 2. This is the S3. This is the general representation of sets in the graphs. Graphs are trees. Coming to this one, disjoint set. Disjoint sets means there is no common element to different sets. That means there is no common element. They do not have any common elements to different sets. Suppose if you take S1 and S2, the elements of S1 1, 7, 8, 9, the elements of S2 5, 10, the intersection of S1 and S2 is the nothing. There is no common element. So that means the intersection of two sets is empty set or phi is disjoint sets. And there is no common element in between two sets, simply named as disjoint sets. Suppose if you take E is the DAA, one set, F is the one more, NIGHT is the one more set of elements. The intersection of A intersection B, nothing but null set or empty set or phi. These are disjoint sets. This is the representation of disjoint sets. Whenever you got questions, can you explain the disjoint sets means you need to write this format, then you will get full marks. First, you will need to represent in the set format. After that, we need to explain it. For example, is the representation of the disjoint sets. So, coming to the disjoint sets in the tree representation, suppose S1 is one set of elements, S2 is one set of elements, S3. There is no common elements. So S1, S2, S3, all are the disjoint sets. Point 1. Suppose whenever we want to combine two sets, whenever we want to combine or combine a union of two sets, that means the elements of one set is added to the another set, we will get the new set, that is S1 union S2. So S1 and S2 are both two distinct sets that are the elements in S1 is here and the S1. That means simply union is nothing but the elements of one set is added to the another set is the union operation. That means combining of elements. Adding a one set elements to the another set is the union operation. So one more operation is the find operation. Find means, suppose in the set, suppose if you want to search any element, suppose if I want to search the three elements from S1, S2, S3, three sets, so from that 3 belongs to S3. Why? Because where S1, S2, S3, three are the distinct sets or disjoint sets. There is no common element in between them. So that at the time, so if you want to search the element, the corresponding set will be displayed in the tree representation of set representation. Suppose if I want to search 3, find out 3, so it belongs to 0, 6, 7, 8. It does not belongs to S1. 1, 4, 9 for S2. It does not belongs to S2. So when it goes to 2, 3, 5, here it is identified. So that it belongs to S3. It is the S3. So that will be displayed. Again, if you want to search 8 elements, so first go to search first tree 0, 6, 7, 8. Here it is identified. So that it belongs to S1. That is belongs to S1. So this is the way to union and find operation performed on the sets. And so this is the common thing you studied in the discrete mathematics. I think this is the basic fundamentals for the graph or sets. So these are the basic operations to perform the data structure. These are the basic operations on the design set. First one is the make a set. Make a set means combining the element that will be placed in on braces itself. It is a set. But in this we need to identify there is a duplicate element. We have to maintain a unique element or a distinct element in the set. Find one. Second one more operation union. Whenever two design sets are available, suppose if we want to combine these two sets at the time, we have to perform the union operation. Or either individual operation elements or set of elements, whatever. So in this union operation, both elements, both the set of elements are combined and for make the third set. That is union operation. That union is nothing but addition, adding up sets. Find operation is nothing but switching of elements for the corresponding tree or set. So just like these are all the basic operations performed by the desired set. Very simple. Next we go to this desired sets. Suppose if you take 10 elements, suppose if you take 10 elements that are divided into three sets S1, S2, S3. నేను ఒకే ఎగ్జాంపుల్ తీసుకున్నానండి. ఎనీ డౌట్స్ దెన్ విల్ ఆస్క్. S1, S2, S3 that are 1, 2, 3 three sets. 1, 2, 3 sets and elements 7, 8, 9 are placed in set 1. 5, 10 is placed at set 2. 4, 6 are placed at set 3. So these three are three distinct sets that will be represented in three format in this one. It is also named as the design set. Why? Because there is no common element in between any sets S1, S2 and S3. These three are the partitioned into three distinct sets. So that also represent in linked list format. So this is the general set format with respect to tree representation. So it is a representation with respect to linked list point. So you know what is the use of linked list. Linked list generally use the pointers. Why? Because linked list is a combination of the two fields. One is the data field, one more is the address field. Address field itself is the pointer field. So generally linked lists are used to store the address of the next pointer or next element or next address. So here the point concept will be loaded. Suppose if I have three sets S1 and S2, S3, so that will be name field that is included S1 and S3. The corresponding address is located like this: S1 178. That will look like this. This is the another representation. Data structure representation. Here the data using data structure is point with respect to linked list. Similarly, S2. S2 consists of 5, 10. 2. Generally we take 2 is the 5 and whatever element you will take the root. But generally you will give the priority to the first element itself is the root. S3. 3, 4, 6. 3 is the root. 4, 6. This is the another representation of the sets. So generally these set techniques are used to represent the different nodes or communication channels available in the settings. This is array representation. Array representation means suppose set 1 has 1, 2, 1, 7, 8, S2 has 2, 5, 10, S3 has 3, 4, 6. Total has 10 elements, 1 to 10 elements, 1 to 10 elements. In this parent node 1 there is no further node, so that is why I will put -1. So that means that the element 1 itself is the root. -1 represents the corresponding elements represent as a root. -1 for 2, so 2 also root. 2 also root. And 3 also root. 3 also. So -1 represents root of the tree. Coming to the fourth element, 4. Where is the 4? This is the 4. 4, its root is 3. Fourth element root is 3. Yes. This is here 3. The element for parent is 3. Here 4 is the children. Next 5. 5, where is the 5? This one. Its root is 2. Its root is this one. Next element is 6. Its root is 3. 6 element. That its root is 3. Next 7 element. 7 element root is 1. This is the root. 8 root is 1. 9th element root is 1. 10th element root is 2. So this is the another representation of the set of elements, array representation. So sometimes directly we are using the set of elements, sometimes we have to use the tree representation, sometimes we have to use the linked list representation. So based on the situation, we have to use the different representation. That is why we have to know how to represent the set of elements in different formats. A set format, a tree format, a linked list format, a array representation format. So whatever format, and each format has its own representation with respect to root, with respect to children, with respect to neighbors, whatever. So like this. These are all the basic representation of the sets. So and that next I have to perform the union operation. So it is one of the union is nothing but one of the design set operation. Union is nothing but suppose the set representation S1 is 1789. Definition is if Si and Sj2 are two distinct sets, that means there is no common element. Their union consists of all the elements access that access in S1, Si or Sj. That is, suppose take an example, S1 is equal to 1789, S is equal to 510. Then S1 union S2 is nothing but combine of two elements. 1, 2, 5, 7, 8, 9, 10. These are the total elements. So this is S1. 1 itself it is the root, generally we prefer. 7, 8, 9 is the children's are given. This complete data not available in our textbook. Listen carefully. S2 is the second set. It 2 is the root element, 5, 10 is the children's. While combining these two sets, we may add S1 to S1 or S1 to S2. ఏ విధంగా మనకి యాడ్ చేయొచ్చు. Any chance we may take. Suppose if S1 union S2, that means S2 is added to S1, that means the second set root is added to first one. So that means one is the first parent, 2 is the second parent, and the children does not affect the main root and also second. Suppose if S1 is added to the S2, the elements of the first set is added to the second one, but the combination of element does not affect. Why? Because they are all distinct elements and disjoint sets. So based on the situation, we have to add the second set to the first set or first set to the second set. This is the union operation. Are you getting? Jntuh?
Yes, sir.
It's clear?
Clear, sir.
Okay, right. Varun, raise your hands. Varun, what is your doubt? Hello? This is the general representation of sets. Coming to the array representation of union operation. Coming to the array representation of, just I explained, this is general basic array representation. So we're combining the union operation. Suppose S1 union S2. Just I explained how to Suppose S1 is this one, S2 is this one. If S2 is added to S1, then we will get this one. S1 is added to the S2, we will get this black diagram. Just I explained to you. So once you will get, that will represent in array representation. Like suppose if S1 is in S2, that means whenever S2 elements are added to the S1 in the representation. So this is the parent node. So that is one. One itself is the root or main root element that will be represented minus one. So always whenever the element has the parent is minus one itself, it is the main root. Coming to the second element, 2. 2 is children of 1. So this is added element, union operation. Next, 3. There is no 3 element. 5. Where is the 5? 5. Its parent is 2. 7. 7 is the children of 1. That means 7's parent is 1. That is 8. Its children of 1. That is parent is 1. 9. Like 10 is the 2 is the parent of 10. Suppose if we add S1 to S2. So suppose if you take 1 as a children of further 2. So that is when this is. Only this value will change. And 2 will become the main parent. This is the main parent. That will be represented. Minus 1 represents the main root of the 5. 5 parent is 2. That is 7 parent is 1. Remaining values does not affect in the disjoint sets. Only by adding S1 to S2 or S2 to S1, only it changes the parent node position only. So this is the array representation for the union. Check this, already explained. Suppose we have 10 elements that are partitioned into 3 sets. Same, just I explained. Suppose if you want search 4. 4 is available, where is this? It is not available in set 1. It is not available in set 2. It is available at set 3. So it returns the S3. Find operational sets. But in tree representation, the find operation is different. But in the set operation, it will return like this. Suppose if I want search 5, again it says S1, not available. You go to the S2, it is found. No need to further search. Why? Because these are the S1 and S2 and S3 are the distinct sets, are disjoint sets. Find operation S1, that is 7. Note in tree representation, ignore the set names and identify the set just by the roots of the representation. That means here in the set representation, just to represent the corresponding set name, either S1 or S2 or S3. But in tree representation, you have to specify the corresponding root value. Depending on that, if you return the root value, the corresponding children will be available at the corresponding position. And that tree law, suppose for this, if I want to find 4, here it returns S4, but here it returns 3. Suppose it is a find 4 means it returns the 3 only. That means it is children of 3 position. Like this. Coming to the union operation. Only 2 operations are the union and find operation. Union and weighted union, find and collapsing find. Jntuh,
Sir,
from this algorithm, what you understand?
simple union like P of I. J is assigned to P of I.
Hello?
Sir,
నీకేమర్థమని చెప్పు ఈ అల్గారం బట్టి.
J is assigned to P of I.
It is a simple union, right?
Yes, sir.
Union means combining the 2 elements or 2 sets.
Yes, sir.
Suppose if you want to perform two sets or any other thing, suppose if I want to perform the union operation I, j, అంటే ఐని జేని కంబైన్ చేయడమే కదా.
అవును సార్.
దట్ మీన్స్ ఇప్పుడు పి ఆఫ్ ఐ ఈక్వల్ జే ఏంటి? Jntuh, are you getting my voice?
Yes sir.
The meaning ఏంటి చెప్పమ్మా? Simple logic. If you understand that one, that is enough. My intent is to combine the I, j, right?
Yes sir.
So the possible I may be added to J may be added to I. Any one element added to another one, right? That means S1 union S2 or S2 union S1. The elements are distinct, that is why it does not affect, right?
Yes sir.
That means here J element is added to the parent of I. Suppose 1, 2 is there in the set 1, it will be represented like this. Suppose if I want to add third element as a J, it is added to parent of I like this. If suppose it is 1, that will be added to I. Here I as a parent of J, right? The ith element act as a parent of J only. Because in the set, suppose 1, 2 is there, that will be union 3. Automatically what we will get? 1, 2, 3, right? Yes or no, Jntuh?
Yes sir.
But in the tree representation, 1, 2 means automatically I treated as a first element. That is I1 is a parent for 2. Whenever we add one element, that is 3 is the one element to this one. So here the first element itself is a road that is added to here. So that is 1, 3 is a representation of that one. Here 1 is act as a parent. This is a simple union. So that will explain by using numbers. Check this one. It is simple find operation. Just I explain. Simple find. Simple finding means searching the root element where it found. Suppose take this one. The root mode of I. P of I greater than or equal 0. That means root element always greater than 0, but not parent. If it is less than or equal, then simply return that value. So only will not accept parents, remaining things are positive. So if I is equal to P of I, suppose if I want to search 6, element 6, so the first the find operation goes to the parent of 6. Parent of 6 is 3. 3 greater than or equal 0. This is true condition. So 6 automatically I become P of I. I become a P of I means P of what is the P of I value? Parent of 6 is nothing but 3. Here I become 3. In the first iteration, it return I. Next in the loop, 3 greater than or equal 0. What is the parent of I? Parent of I 3. 3 parent is minus 1. Minus 1 greater than or equal condition 5. So 3 itself it is the root. So finally it return the parent of 3, that is it return the 3. Parent of 3 is nothing but minus 1. That is nothing but parent 3 itself it is the root. Clarity వచ్చిందా?
Yes sir.
ఏమని చెప్పి కూడా. So if I want find the 4 అన్నాను అనుకోండి, ఎలా క్యాలిక్యులేట్ చేస్తావు?
4 అంటే P of 3, sir.
First, find the 4, right?
Yes, sir.
Find the 4 means here I is equal to 4. P of 4 is equal to parent of 4 ఏంటి 3 కదా.
Yes, sir.
3 greater than or equal to 0, right?
Yes, sir.
So condition rule, I is equal to P of 5. P of 5 is nothing but 3. So what is the I value?
3.
3. Again the loop goes to here, right? P of 3 ఏంటి?
-1.
-1 means
Condition fails.
-1, right? -1 means itself it is the parent. ఏ రూట్ అయినా సరే మైనస్ వాల్యూస్ ఉంటే ఇట్ ఇస్ itself it is the root. So -1. The condition fail కదా. What is the value? 3 only, right?
Yes, sir.
It hidden 3. Is there any logic for the find operation?
No, sir.
Right. ఇది ఒకసారి చూడు చంద్ర.
Yes, sir.
ఏమర్థమైంది ఫ్రమ్ దిస్? 5:30 are you there? చంద్ర చూడమ్మా, ఎక్కువ మంది రెస్పాండ్ కావట్లేదు.
Yes, sir, here.
You will explain this one 5:30. I have to perform simple union operation only. Here n elements are there. Unable to explain?
No, sir.
Okay, right. I will explain. Suppose here n elements are there. So on that I have to perform the operations like union of 1, 2. That means union of 1, 2. Next union of 2, 3. Like union of 3, 4. Like up to n. So here I degenerated one tree 1 to n. Then I perform a.
Yes, sir.
So link is built in between 1 to 2 for this one, 2 to 3 for this one, 3 to 4 up to n, right? By using the union operation. So its complexity is for union. So at a time you can able to perform one operation, that is the simple, it is the complexity this one. For n-1 operations it required n order of n, its complexity. Is it clear?
Yes, sir.
For one operation it required only 1 clock, union of 1, 2, only 1 clock required. Suppose 1 unit of time n of. Suppose if you want to perform n operations, it required order of n is its complexity. అంతే కదా చందు? కన్ఫ్యూజ్ అవుతున్నా? Are you confusing?
No, sir, clear.
But can you explain for the find operation? For one find, suppose if you want to calculate first find, it required only one operation is enough, right? For find operation, suppose n finds is required n square. Ela ante chudandi, for one element 1, for second elements it required 2, second 2, third one 3, like this. Sum of first n numbers is nothing but n into n plus 1 by 2, nothing but order of n square. This is the find operation complexity. That is why its complexity is order of n square for find operation in the trees. And also its time complexity varied with respect to different nodes in the tree in different formats. Suppose for this union operation its complexity is this one. Suppose if I built in the binary tree format, it will take very less time. Depends on its depth, the complexity will be varied. So this is the simple analysis for simple union and simple find operation. But every time the simple union, simple find is not enough to build the tree and to perform the operations, either union or find operations. Suppose the depth of the tree increases, it is somewhat difficult to search the elements, to combine the elements. Suppose 2000 elements are there. At the time, the union operation may take more time. Suppose if you are using the Google browser, by search an element, you use a simple union, it will take more number of seconds to search anything. So to overcome the problems, we have to use the weighted rule. Weighting rule of union. Weighting rule of union. In the weighting rule of union, simply a priority kunte daniki small sets add cheyadam. That means if I comma j two sets are there, if more number of elements in one set and less number of elements in second set, then automatically set is added to another set which has less elements as the children, greater elements as the parent. Suppose if you take 1 to n elements in this one, in the first step. This is a textbook example. So if the number of nodes in the tree root I is less than the number of elements in the root j, then j become the parent of I. Ante ekku number of children unnade will become the parent. The second small set added to the parent set. This is the weighting rule. So here 1 to n individual elements are there. So initially all are in equal level. Initially I form the union of 1 comma 2. So 1 is the same level, 2 is same level, 1 comma 2. Here 1 is treated as the parent. Next 1 comma 3. 3 is added to the 1. That is like. So union of 1 comma 4 like this. Union of 1 comma n. So except to 1, remaining elements are added to the 1. So whenever we want to search, first we will go to the root element 1, then we will go to the branching. Easy to create the tree format like this. This is the weighting rule of union. Weighting rule is very important. Very simple. In the first step, all are individual elements. The second step, 2 is added to 1. That means 1 is the parent node and 2 is the children. Third element is the children and 1 is the parent. Both like. Rest of 2 to n elements treated as children that are added to the 1. 1 is the parent node. 1 is the parent node. This is the weighting rule. By using this weighting rule, we build the trees. So on this basis, the searching technique and finding technique is become very fast. So that will be represent like this. So generally, check this one. We have to use this algorithm. That is the weighting rule algorithm. So first I will explain an example, then I will go to the algorithm. So suppose you take 8 elements, 1 to 8 elements. At the first level, it's depth is 1. That is only one element exists. All are individual elements. All elements treated itself it is the roots. -1 itself is the root. -1 ఎందుకు పెట్టాము? Suppose this is the ground level, it is a 0. So tree becomes root down. That is negative numbers. So that is why in the algorithm also this point P of I is minus count. Minus count indicates the depth, but not branch. Develop counting అనేది minus లో చెక్ చేస్తాం in the weighting rule. So itself it is in the tree. Chandu,
sir.
ఈ height -1 అంటే ఏంటి ఇక్కడ 1 అనొచ్చు కదా. ఇది గ్రౌండ్ అనుకో, ఇది 0 కదా.
Yes, sir.
పైకి వెళ్తే
-1.
కిందకి వెళ్తే -1 కదా.
Yes, sir.
Yes. So whenever moves down, become a root. So here all elements are in the root position, right?
Yes, sir.
Or in 8 individual elements are itself they are the roots. So its weight is -1. That means that tree has only one element that is treated as a root. By applying the union of 1, 2, 3, 4, 5, 6, 7, 8, check this one. By applying 1, 2, 3, 4, 5, 6, 7, 8. Then here I am performing 4 union operations. అంతే కదమ్మా. ఇప్పుడు ఎంత డెప్త్? 1 element, 2 elements from ground, that is -2 level. అదే కదా. So for this, total you have total 4 subtrees are there. So for first element 1 has total 2 elements. Itself it is a 2 elements. That means its depth is true, and minus indicates itself it is the root. 2 has the parent 1. This is the parent. 2 is the children of 1. 3 minus 2. That means minus 3 itself it is the root. And it has total 2 elements, 3, 4. 1 element, 2 element. And 4 is the children of 3, that is 5 itself it is the tree. Minus indicates itself it is the tree. So 5 has 2 elements. 6 is the children of 5. 7 itself it is the root. 8 itself it is children of 7. Total 4 subtrees at level 2. So in the next, that is union of 1, 3, union of 5, 7. So union of 1, 3, combining these two and these two. That means this subtree is added to this one. Union of 1, 3. 3 is joined to 1. 7 is joined to 5. So what will happen? So again, it is better. Student error representation 1. The roots minus represent itself it is the root. And 4. It has total 4 elements. 1, 2, 3, 4. This is 1, 2, 3, 4. So these 2 elements are added to the previous tree. Previously it has 2 elements. 2 more elements added from 3. Total 4 elements are there. From T, 2 is the children of 1. That is, its root is 1. 3 is added to 1. That becomes, in the previous case, 3 has -2. Whenever it acts as a tree, when it is added to the 1, that 3 becomes children of 1. Similarly, 4 children of 3. So it's 7, 8 added to the 5. That is minus represent itself it is the root. 4 is the total number of elements available in the corresponding tree. 6 is the children of 5. 7 is the children of 5. 8 is the children of 7. This is the third level. Level 1, level 2, level 3. And again I have to combine 1, 5. This is the 1, this is the 5. Then I will get the tree like this. I am combining 1, 5. It is a level 1, level 2, level 3, level 4 tree. Same. This tree is combined to this one. This tree is combined to this one. What will get again? So this is tree 1 has 4 elements, tree 5 has 4 elements, total 8 elements. But 5 is added to the 1, that becomes 4 plus 4, 8, and 1 is the main root. 2 is the children of 1, right? 3 children of 1. 4 is the children of 3. A 3 acts as the parent. Like 5 is added to the 1. So that is the parent is 1 for the 5. 6 is children of 5. 7 children of 5. 8 children of 7. So from this is while fourth level, what I explain? Parent nodes. This is the parent node. This is the parent node. This is the parent node. 3 parent nodes are there. Parent ups. It is the parent node. It is the parent node. This is the parent node. Like 4, 5 parent nodes are there. 1 is the main parent. 3 is the sub parent. 5 is the sub parent. 7 is sub parent. So this is the weighted union rule. So from this, I will explain this algorithm right now. So initially P of I, parent of I and parent of J. So parent of I means one element, parent of J is the one more element. So by adding this value, P of I, P of J, like -1 and -1. Whenever combining 1, 2, what will get -2? This -2. P of I greater than P of J, parent of I greater than parent of J, automatically P of J added to the that one. If it is true, P of I, J is added to the P of I. So like this, parent of I 1 greater than parent of initially both are equal, then we combining this one like this by using this value. So after assigning P of J is equal to M, the root value is added to that one. If I is less than the J, then I is greater than J, then add like this. Otherwise, use J has a fewer nodes than treated as this. This is a simple algorithm. So, once we will go through it, this block diagram, simply we will get the union algorithm. So, initially all are in individual elements. By combining these two elements at the depth level 2, we will get like this. After combining to depth level 3, we will get like this. Just I explain. This is like this is the tree. This is the collapsing find algorithm. In the next class, I will explain this one. And also, you will go through the union rule once again. Tomorrow, I will explain the collapsing find for you. Any doubts from this one? Any doubts? Not listening properly? Ready?